All right, guys, we are back for the second half of our cybercrime course on networking. And we're going to start off today by talking about speed, right? We always hear uh, internet service providers bragging about how fast their internet service is. And one of the things I wanted to start off with was uh, making sure you understand there are two different measures of speed when it comes to network communications. There's bandwidth and there's latency. And we're going to go back to our kind of road analogy, right? So, latency is essentially how fast can one car get from A to B. And that's going to be dependent on very different things than bandwidth, which is essentially how fast can we get a million cars from A to B, right? If there's only one car on the road, you're much more concerned with things like the speed limit, right? But if there's a million cars on the road, you're going to be much more concerned with, how many lanes wide is it, right? So latency is a measure of how fast you can get one packet of information from you to the target. Bandwidth is about how fast you can get a boatload of information from you to the target. And those are sometimes, similar enough that they're essentially the same thing, but other times for other purposes, they're completely different. And you might vastly prioritize one versus the other, right? So when you are purchasing internet service from a internet service provider, they will usually advertise their speeds for bandwidth in megabits per second. Notice that that's not megabytes per second, it's megabits per second. They advertise it that way so that the number sounds higher and it sounds fancier and better. But this chart here, it's a few years old now. These numbers are going to be different, but the general pattern is essentially still the same. If you look at internet speeds worldwide, Japan and South Korea have by far the fastest internet in the world. Then you get some kind of northern European countries. USA, we're kind of middling. We're kind of middle of the pack. And then when you look at costs, it's almost the same as speeds, right? The fastest internet is also usually the cheapest. The slower internet is more expensive, which is kind of a weird backwards way to do it, but that's the way it has worked out in the world to now the USA, the country that began the internet, has kind of midland speeds and midland prices. But if you want to test your speed, test how fast you can connect to the internet, there's a few different ways to do it. I mean, for one thing, you could just go to, Google an internet speed test, and that will tell you in a lot more detailed way how fast you're going. But there are some other simple ways to test the connection and test the speed between you and some target, right? So one of the things we can do is we can bring up a command prompt, or I'm going to use a PowerShell prompt here. And this is old school computing, right? This is, this brings me back to the days of DOS. And yes, I am old enough to remember the days when the entire operating system looked just like this. There was no mouse. There was no graphics. It was just text on a black background, just like this. That was the entirety of your computing experience. Yes, I realize I'm old. But what we can do is use the ping command, P-I-N-G, right? And then we do space and a target. And you can choose any target on the internet you want. If you know their IP address, you can use that. But if you need to use, say, a web address, you can. So we're going to do www.paypal.com and see if that has a ping. Well, yeah. So our computer went out to the DNS system and it said, hey, my user wants to know paypal.com. Can you give me the IP address for that? And the DNS system said, sure, it's 199.232.33.21, right? And then my computer, using this ping command, sent one packet of information to that target and said, hey, would you please reply to me? And PayPal said, sure, and sent a reply, right? So we did this 4 times. We sent 4 different packets of information to that same target. Each packet was 32 bytes in size, and each one took either 24 or 25 milliseconds to kind of get there and back. And there were 0 lost, right? So if you're having a connection issue with a certain website or with a certain service, you can just use this ping command to see, are packets getting through at all and it's just taking a long time, i.e. this return time is really high, or are they just all getting dumped, right? And you have to be careful because some targets, some web services have turned off their ability to reply to ping. PayPal clearly has not. PayPal clearly will still reply to pings, but some services have turned that off, right? And 24 milliseconds, that's a pretty good latency. And remember, that's not a measure of bandwidth. That is only a measure of latency, how fast one packet of information can get there and back. This is not a measure of how fast I could download 1 terabyte worth of data from PayPal.com. The second tool we can use here is traceroute. So we do trace RT space and then the target, right? So we'll do www.paypal.com and let this run. And what this does is instead of just pinging the target, it pings every device between my computer and that paypal.com web server. Now, this first jump, I'm assuming is from me to my router, and it's taken a little bit of time for the routers, my personal home router, and then the internet service providers, services and servers that I'm going through to identify themselves, even if the latency is pretty good. So remember in that graphic I showed you where we're talking from device A to device B, each packet is going through a whole bunch of different servers along this global internet before finally getting to the server it's trying to talk to. This is just showing me every single one of those devices, every single one of those servers that my information is going through between me and PayPal.com. And then whether each one is responding, who each one is, and how long that response is taking. So you'll notice that there are 7 hops. There are 7 devices between me and PayPal.com. Each one is identified with at least an IP address, but a couple of these also have kind of server names. Each one of these is a different server run, I assume, by this company 1299.net. And so this tells me each device between me and PayPal.com, whether they're responding, how fast that response takes. And this can be a very useful tool when trying to figure out what the connection looks like between you and some target. Now, security. When talking about internet security, this could be a whole series of courses all on its own. Security is such a huge deal. Every device has to have or should have security features built into it, although a lot of them still don't, even in this day and age. So this is the barest of tiniest of little dips into this subject. And I want to talk specifically about your home router, right? So the thing that you connect to in order to get the internet in your home, right? Most of us will have some kind of Wi-Fi router. Some of us still have, the hardwired where you actually have to cord running from your router to your devices. But each of those is kind of the first line of defense if somebody is going to come in across the internet with some kind of nefarious purpose in mind, whether it's to steal your bank account passwords or eavesdrop on your internet communications or whatever. So each one of these routers should have, as a basic security procedure, a firewall. Okay? And how a firewall works and what it does, it's, again, a lot more complicated than this, but this is just kind of the really basic overview. Any given internet connection has to have a designated port. So imagine that my router is not just going back to our road analogy, right? We've got the internet is, packets are cars driving down roads, right? And if you want to get into my house, if you want to send packets through the internet into my desktop computer here, you have to go through my router to get there. And that router, you can imagine in this kind of road analogy, as a big giant brick wall with thousands of different doors on it. Okay? And by default, all of those doors are just open. And any packet that wants to come through can go through that open door and into my house and onto my property and interact with my machines. But each type of communication has a different port it is assigned to use. So web browsing will use a certain port number. Email uses a certain port number. Watching a YouTube video, all those packets will come through a certain port number, a certain door number in the analogy, right? And what a firewall does is a firewall says, look, if my user doesn't want to use this service, let's not have this door be open. Let's close this door, right? So if I'm not using the service for, say, the PC Anywhere software that allows people to remotely utilize your computer, figure out what port that service is using and just close it. I don't want to use it as the user. So if somebody is sending me messages through that door, through that port, it's gonna be a bad actor trying to do something they shouldn't be doing. So let's just close that port, close that door, and now those packets can't even get into my house, can't touch my computers because my router has shut that door. It's restricted access for that type of packet to get onto my home intranet. I hope that makes sense, right? And again, this is firewalls do more than that. Ports are an incredibly complicated process. There's tens of thousands of different ports used for different services, everything from video gaming to watching Netflix to doing Zoom calls. Those all use different ports and different protocols and different everything. But the important thing is those routers, one of its basic functions is to set up this firewall so that you have this kind of sense of security. You can close ports you're not using. You can inspect packets that are coming in through open doors and not just letting anybody come through, but inspecting them and saying, hey, are you sure you're supposed to be coming through this door? So it's essentially, the gate guard or the doorman of the digital world. Now, the thing we're going to end on today is a little bit of policy and my own humble opinion. But we're going to talk about net neutrality. Okay? So since the beginning of the internet has been neutral, i.e., every device that my packets go through treat my packets the exact same as any other packet. Those routers between me and PayPal.com didn't care if that packet they were serving was a ping from me or an actual customer of PayPal's or the CEO's trying to send an email. Doesn't matter. Every packet was treated the exact same with no regard to the source or the destination or the contents of the packet. About 10, 15, 20 years ago, internet service providers started realizing that there is no legal requirement for them to do that. So they started kind of prioritizing some packets over others. They started trying to say, well, if this service pays me more money, I will treat their packets, kind of let them jump to the front of the line so that their users gets higher speed through my internet service provider to that service. And if you don't want to pay, I will slow down your packets, put them to the back of the line. So any of my customers who use your service are going to have, a slower experience, right? And this really upset a lot of people, including me, I must admit. Artificially making things faster or slower, depending on the source or the content, is kind of has very big ramifications for how the internet works and how the entire structure is designed. And kind of the ultimate nightmare scenario is that the internet becomes more like cable television, where I don't, right now I can just buy a connection through an internet service provider, and then I get access to anywhere on the internet I want to go. But without net neutrality, there is nothing stopping my internet service provider from saying, hey, you pay, $30 a month for basic internet access, but if you want to reach Netflix, you have to pay us an extra $5 a month in addition to what you're paying for Netflix. If you want to reach, this news site, you have to pay an extra $2 a month. If you want to reach YouTube, you have to pay an extra $20 a month, right? Because without that policy of net neutrality, without being required to treat every packet the same, those internet service providers can theoretically dictate who sees what, how fast, how slow, or whether they even see it at all, right? So recently there was probably more like 10 years ago now, the FCC put in a rule that said, no, the internet has to be neutral. And then a new presidential administration appointed new people to the FCC, and they said, oh, no, we don't care about net neutrality anymore. That's no longer a rule. And then we got a new administration that said, no, put new people on the FCC, and they are now trying to push for net neutrality again and making rules that force internet service providers to treat all packets the same, to not dictate what their end users can and can't see, or what services are artificially sped up or slowed down. So this is a really important topic, both for me personally and I believe for the internet as a whole. And I highly recommend you kind of do some more research, read more into net neutrality, figure out what it's all about. Because again, that was just a very brief, high-level overview. But anyway, that is the end of this section. Thank you so much for watching. I'll see you in the next one.